Welcome to another Exam Strategy Explainer. I am your host, The Strategist, and today we are tackling one of the most crucial, high-stakes areas of the Cambridge Mathematics syllabus, coordinate geometry. Think of this session as the weightlifter approach to your exams. What do I mean by that? I mean maximum effort in short bursts. High-mark math questions require explosive power and absolute precision. You can't just flail around and hope to lift the weight. I see this all the time with past papers, especially in the 0580 syllabus. Let me introduce you to two students we've been working with. First, there's Alex. Alex is a hard worker, but Alex overloads answers with raw mathematical facts and formulas, yet provides zero actual analysis of what the question is asking. And then we have Sam. Sam rushes. Sam has the speed but completely misses the command word requirements in the prompt, leaving easy marks on the table. Today, we are going to fix both of those fatal flaws by looking at the very foundation of coordinate geometry, a system dreamt up 400 years ago that literally built the modern digital world.
Look, when someone straps on a virtual reality headset and reaches out to interact with a seemingly three-dimensional object in thin air, the computer tracking their hand movements needs a way to rigorously understand space. It relies entirely on a coordinate mapping system invented by French philosophers, long before computers, digital screens, or VR headsets ever existed. Now, why does this matter for your Cambridge 0580 or 0606 exams? Because Cambridge examiners are testing your spatial mapping skills in the exact same way. When a question asks you to find the midpoint or the gradient, they are testing if you can accurately navigate a two-dimensional space, just like a programmer does. Sam rushes through these spatial questions, calculating a quick number, but failing to realize the command word was coordinate, meaning the answer needs an x and a y value. Alex, on the other hand, writes down the distance formula, the gradient formula, and the midpoint formula, hoping one of them gets a mark, totally overloading the paper. We are going to apply our weightlifter strategy to focus your power perfectly. All right, let's look at the blueprint for today's session. We'll briefly cover the origins of coordinate geometry and meet three French mathematical geniuses to see how they approached problem solving. Then, we'll see how Descartes linked two massive worlds of math. After a quick look at Pascal and Fermat, we are going to transition into the transformation stage. We will map this directly onto your straight-line graph syllabus and hand you the ultimate coordinate geometry toolkit to absolutely ace these exam questions. Section 1. The origins of coordinate geometry in the 17th century. To build the explosive mental muscle needed for top-tier exam performance, you need to understand how the foundational heavy lifting was done. In the mid-17th century in France, there was an absolute explosion of discovery. The mathematicians of this era didn't just memorize formulas. They invented them to solve specific, real-world problems. This is exactly the mindset shift I need you to make when you walk into your exam. Notice the overlapping lifespans of the three great mathematical giants of this era. We have René Descartes, born in 1596, Pierre de Fermat, born just a few years later in 1601, and Blaise Pascal coming into the picture in 1623. These great minds lived at the same time, they collaborated, they challenged each other, and they continuously pushed the boundaries of what humanity understood about numbers, space, and probability. They essentially formed study groups, much like you should be doing right now, to elevate your great potential. Speaking of elevating your potential, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It is the single best way to ensure you are getting the explosive strategy bursts you need for your Cambridge papers. Now, back to our trio. These guys were constantly peer-reviewing each other's work, which is exactly how we help Alex and Sam spot the flaws in their own past paper answers. Section 2. Three French mathematical geniuses, the Avengers of early math. I genuinely love thinking of these three as a superhero team. They weren't just dusty historical figures quietly scribbling in isolated dark rooms. They were brilliant, dynamic, innovators, actively questioning the very nature of reality. When you sit down to tackle a tough paper 4 extended question in the 0580 syllabus, you need to channel this energy. You need to look at the geometry puzzle on the page and attack it with the confidence of an innovator, not the panic of someone who forgot to memorize a textbook page. Section 3. Descartes, linking two worlds, where philosophy meets mathematics. Now, what's really fascinating about this slide is how Descartes' approach directly mirrors what top-scoring Cambridge students do. He refused to see disciplines as separate. He linked abstract logic with highly practical calculation. When I look at Alex's exam papers, I see someone separating the worlds. Alex knows the math facts, but lacks the analytical logic to link them to the specific command words in the prompt. Descartes is going to show us how to bridge that gap. René Descartes wore two major hats. He was a philosopher and a mathematician. Now,
Our historical sources note something incredibly reassuring for any student who sometimes struggles with arithmetic. Descartes wasn't always considered quite as natively talented at raw calculations as his peers Pascal or Fermat. Let that sink in. The guy who invented the foundational tool of modern geometry wasn't the fastest calculator in the room. But Descartes had a monumental vision. He firmly believed that all nature could be explained in terms of mathematics. He had a systematic strategy. Just like a weightlifter doesn't just throw weights around, they focus on form, Descartes focused on the structure of the problem, a technique that is absolutely essential for unpacking high-mark coordinate geometry questions. His mathematical breakthroughs were rooted deeply in his philosophical inquiries. In his famous book, The Meditations, he asked a simple, incredibly profound question: how and what do I know? This is the exact question you must ask yourself when applying our Peel framework to math questions. Point, evidence, explanation, link. What is the point of the question? What evidence or data is given to me? What is my step-by-step explanation or working out? And does my answer link back to the command word? When you read a problem, channel Descartes. Ask yourself, what do I know for absolutely certain based on the coordinates provided? Breaking down reality to absolute certainties sparked a revolution in human thought, and it will spark a revolution in your exam grades. Before Descartes, the mathematical world was largely divided into two completely separate camps. You had algebra, which dealt with equations, unknown variables, and numbers, and then you had geometry, which dealt with shapes, lines, angles, and physical space. Alex loves the algebra side, blindly plugging variables into equations without thinking about the shape. Sam loves the geometry side, sketching lines quickly but failing to derive the algebraic equation required by the examiner. Descartes' massive, world-altering contribution to human knowledge was building a bridge between them. He realized you could use algebraic equations to describe geometric shapes, and you could use geometric graphs to solve algebraic equations. This synthesis is the key to top marks. This monumental link gave us a system we still use to map everything, from those video games we talked about to architectural blueprints and, of course, your exam papers. The familiar X and Y coordinate system we use today is formally called Cartesian coordinates. Yes, Cartesian is derived directly from the name Descartes. Every single time you plot a point on an X and Y axis or calculate a gradient, you are using a tool specifically named in his honor. You are wielding a 400-year-old weapon of logic. Section 4. Pascal and Fermat's discoveries, the prodigy and the master. While Descartes bridged algebra and geometry, Pascal and Fermat made parallel discoveries that shaped probability, calculus, and number theory forever. Now, we are about to head into our interactive workshop phase to test your analytical skills against their theories. But first, listen closely. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. You absolutely need that weekly burst of exam strategy to keep your form perfect. Now, let's look at the raw data of these two masters. Get ready for our first interactive challenge. I call this the data scan. I'm putting a 60-second timer on the clock in our minds. Look at this complex data table comparing Blaise Pascal and Pierre de Fermat. Your job in an exam is to quickly extract the core trend. Go. Okay, on the left, we have Pascal, a child prodigy. At just 16 years old, he stated and proved Pascal's theorem, sometimes called the cat's cradle, relating 6 points on any conic section. He founded probability theory and created Pascal's triangle. On the right, Fermat. He invented number theory, discovered probability alongside Pascal, and our source text argues he was at least Newton's equal as a mathematician. The core trend? Collaboration and overlapping genius. In an exam, if you were given a data table, don't read every single number like Alex does. Scan for the extremes, the comparisons, the highest marks. That's how you save time. Now for challenge 2, find the flaw. I want you to look at Fermat's most famous mind-bending puzzle. Fermat's last theorem is derived directly from something you know, Pythagoras' theorem for a right-angled triangle, where x squared equals y squared plus z squared. Fermat confidently stated that if the index, meaning the power, is greater than 2, and x, y, and z are all whole numbers, then the equation is never true. He essentially wrote in the margin of his book that he had a spectacular proof, but the margin was too small to contain it. Imagine Sam writing an exam answer like that. I know the answer, but I don't have time to write the working out. The examiner is going to give that a massive red 0. You cannot just state a claim, you must provide the mathematical evidence and explanation. Fermat got away with it because he was Fermat, but you won't get away with it in your Cambridge exams. And here is the ultimate proof that you must show you're working. Because Fermat didn't write his proof down, it drove mathematicians absolutely crazy for centuries. It took over 300 years until 1995, when the brilliant English mathematician Andrew Wiles put in the explosive weightlifter effort, locked himself away, and finally proved that Fermat's bold claim was actually mathematically correct. 300 years to get the green check mark from the examiner. This brings us to challenge 3, speed writing. When you know the method, you must execute it quickly and flawlessly. Let's translate this historical persistence into your actual syllabus toolkit.
Section 5, the straight line graph syllabus, putting history into practice. We are now transitioning from the theoretical to the highly practical. We are going to take Descartes' magnificent invention of the Cartesian plane and turn it into your specific goals for the 0580 coordinate geometry module. It's time to build your final answering system. There are exactly 6 core syllabus objectives in this module. I don't want you to think of these as arbitrary rules you have to blindly memorize. Instead, think of them as 6 specific, highly powerful tools left behind by these French geniuses. To guarantee top marks using these 6 tools, you need 3 rules. Rule 1, command word decoding. Know exactly what the question is asking. Rule 2, Peel framework application. State your point, show your evidence, explain your working, and link to the answer. Rule 3, the time management matrix. Maximum effort in short bursts on the high mark questions. Let's look at your 6 tools.
Section 6, your coordinate geometry toolkit. Syllabus objectives E3.1 to E3.6. We are going to walk through these exact objectives step by step, so you know precisely what the examiner expects of you. If you master these, you have a 100% mark potential on this topic.
Your first 2 tools represent the foundation. E3.1 requires you to demonstrate familiarity with Cartesian coordinates in 2 dimensions. This means comfortably navigating the x and y axes. This is where Sam loses marks by rushing and swapping the x and y values. Don't let speed destroy your foundation. Tool 2, E3.2, is where the heavy lifting starts. You need to calculate the gradient, the steepness, of a straight line from 2 coordinates. Remember the formula, the change in y divided by the change in x. The examiner is actively looking for you to explicitly show the substitution of the numbers into that formula. If you just write down a final fraction, you are throwing away method marks. Show the evidence, show the explanation. Moving on, E3.3 expands your spatial awareness. Given the endpoints of a straight line, you must calculate its total length using a variation of Pythagoras' theorem and pinpoint the exact coordinates of its midpoint. This is where Alex overloads the paper. If the command word is calculate the length, do not waste 4 minutes calculating the gradient in the midpoint as well. Read the command word. Then we arrive at E3.4, perhaps one of the most famous equations in all of mathematics, y equals mx plus c. You are expected to interpret this equation and obtain it from a graph. This is Descartes' dream realized, seamlessly linking the algebraic variables with the geometric line. You need explosive power here. Identify the gradient for m, find the y-intercept for c, and state the final equation clearly.
Finally, your toolkit is completed by understanding how lines relate to one another. E3.5 asks you to determine the equation of a line parallel to a given line. Remember, parallel means they have the exact same gradient. E3.6 is the ultimate test, finding the gradient of perpendicular lines, the negative reciprocal. This is where the 4 and 5 mark questions live. This is where the weightlifter puts up the massive numbers. Listen to me closely. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. You have to put in the reps. Mastering these final 2 steps means you have complete command over the orientation and intersection of lines on a Cartesian plane. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by without having this strategic advantage.
This brings us to a final provocative thought. You aren't just memorizing random formulas for a test. You're learning to wield the exact same mathematical superpower that Descartes invented, the same logical system that Fermat and Pascal built upon, and the very same spatial foundation that powers today's virtual realities and GPS satellites. By mastering these 6 syllabus objectives with the weightlifter strategy, by not overloading like Alex and not rushing like Sam, you are stepping into a legacy of absolute genius. So, How will you apply this 400-year-old system to conquer your own coordinate geometry challenges today? Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams, your Cambridge success starts here.